This tutorial is all about the idea of yield, in other words, how much product we get compared with how much we expect to get in a chemical reaction. You might be expected, according to the specification, to recognise why we don't get 100% yield in a chemical reaction, particularly if you're given some experimental details in an exam question. One substance you might have made in chemistry is copper sulfate. Copper sulfate's a blue crystalline chemical which is dissolved in water and then used in electroplating. It's made usually in a neutralization reaction involving sulfuric acid. One method of making copper sulfate is the reaction between an acid, sulfuric acid, and a base, copper oxide. The copper oxide doesn't dissolve in water or in the acid until it's warmed. So copper oxide is added to the acid and stirred while warming, and the copper oxide will react with the sulfuric acid to make copper sulfate and water. But some copper oxide is left over unreacted, in other words is in excess. So this is separated by filtering the mixture. The copper sulfate solution goes through the filter paper, whereas the copper oxide is trapped on the filter paper. The next stage then is to remove the water, and that's removed by heating. The water is evaporated off until we've got a quite concentrated solution, at which point the copper sulfate crystals are then allowed to form in the liquid. To separate these copper sulfate crystals away from the remaining liquid, they are again filtered, and that leaves some copper sulfate solution behind. The copper sulfate crystals then dried between filter papers to give you some dry sample of copper sulfate crystals. Looking at the calculation, and if we round the relative atomic masses to the nearest whole number, the relative formula mass of copper oxide would work out at 80 and sulfuric acid would work out at 98. The copper sulfate would work out at 160 and the water at 18. Conservation of mass here, that the mass of the reactants is the same as the mass of the products. So in theory, if I'd used 80 grams of copper oxide, I could have got 160 grams of copper sulfate. If I'd used 8 grams of copper oxide, I could have got a tenth of that, 16 grams of copper sulfate. Now, rarely do we get 16 grams of copper sulfate crystals in this experiment, and the reason is that they are lost during the method. There are very many reasons why some of the copper sulfate is lost during the process. Some may, for example, remain on the filter paper when the solution is filtered. It remains soaked into the paper as copper sulfate solution. Some of it may spit out during the evaporation process. Some obviously remains in the mixture when the crystals are filtered off, because it's crystals of copper sulfate in a solution of copper sulfate, and some will be lost in transferring from there to the filter paper, for example. So in summary, when we make a product in a chemical reaction, we don't make as much mass as we expect, because some reactions don't go to 100% completion. In other words, not all the reactants actually make the product. Some remains in the flask when it's poured out. Some of the product is lost in the purification process, being stuck to the evaporating basin or filter paper. Some is lost in the purification process when it's being recrystallized. So the main areas where it's lost are filtration, lost in transfer from container to container. Not all of it reacts, and in the case of making liquids, some of the liquid might evaporate. So if we work out the yield, it's a way of comparing the amount of product that we actually make, called the actual yield, to the amount expected from the experiment, which is what's called the predicted yield. If you've got 100% yield, this means that you've not lost anything. If you've got 0% yield, of course, this means that you've lost everything. And in order to calculate the percentage yield, you need to use this formula, which you will have to learn. This will not be given to you on the exam paper. So percentage yield is the actual yield you get, divided by the predicted yield, which is the theoretical yield, if you like, multiplied by 100 to make it into a percentage. And returning to that equation, which I stress you must learn, the actual yield is the mass of the product that can be actually isolated and weighed at the end of the process, whereas the predicted yield is the mass of the product which is theoretically possible when you use the equation and when you know the mass of the reactants that you're using in order to make it. Mary predicts that she makes 4.8 grams of fertilizer, and she actually makes 4.2 grams, so calculate her percentage yield. Now in this exam question, we have to use that equation, which is that the percentage yield equals the actual yield over the predicted yield times 100%, which is equal to 4.2 grams over 4.8 grams times 100%. If we work out that calculation, it comes out at 0.875 times 100%, which is 87.5%. Mary's actual yield is less than her predicted yield. Suggest why using her method to help you. Well, unfortunately, the first part of this question isn't in there, but the standard reasons are loss in filtration, or you could say loss in transfer between pieces of equipment. The answers then are 87.5% and loss in evaporation, loss in transferring liquids, loss in heating, the idea of material being left in equipment but nothing to do with gas because it's not a gas being made here. And finally, another calculation from another paper. Anne-Marie makes some ammonium sulfate in a laboratory. She predicts she's going to make 3.5 grams of ammonium sulfate. She actually makes 2.1. Calculate the percentage yield of ammonium sulfate. Well, again, percentage yield equals actual yield over predicted yield times 100%, which is 2.1 grams over 3.5 grams times 100%, which equals 0.6 times 100%, or 60%. Now in these calculations then, the main thing you need to remember is that the actual yield goes over the predicted yield. The actual yield is always going to be smaller than the predicted yield. If you end up with an answer which is greater than 100%, you've got them the wrong way round. It should always be less than 100%. So if you get over 100%, just check your calculation, make sure you've got these two figures the right way round. And there we are, 60% scores 2 marks, but remember you even get 1 mark for writing the correct equation, so make sure you include that in your answer just in case you make a silly slip.